Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is another problem with aircraft moving along the straight line in one dimension with a constant acceleration. We know the initial speed v0, and we know that it traveled during t equal, and I put it capital, t seconds. And we also know something about the last 2 seconds of his travel. We know that it covered some distance d, and they tell us that this distance is 380 meters. And they also gave us the initial speed, which is 360 kilometers an hour. So already as I write it, I see that there are seconds and meters and kilometers and hours, so not all the units are the same. When we will be plugging the numbers in the very end, we will have to convert those to the same units, namely meters and seconds. And so this is seconds, meters, so this has to be converted. But anyway, it's all going with the same acceleration, and we have last distance, and it's so tempting to write d equal v final squared minus v1 squared over t2a, and this is v final, and this is v1. v1 is the speed in the end of this interval, and it also in the beginning of this interval. Okay, so this is the first formula that we can have here, d. And we can immediately see that there are 3 unknowns, v final, v1, and a, they all not known. v final is this speed, v1 is at that point, and accelerations are asked. So we can ask ourselves what variables we're not using yet. They gave us v0 and they gave us t, and we're not using them. Oh, and we have v1 and v final. Click a pause and try to write 2 extra equations that will connect this v final and v1 and those knowns t and v0. And I hope you did it correctly, but let me do it. So v final, actually it's v0 plus at, right? Because we traveled for a period of time t, and we have this, and we acquired that much speed. v1 is the same v0 plus a, but we traveled significantly less, 2 seconds less, t minus t. And those are 3 equations. And now we're happy, we have 3 equations and we have 3 unknowns. So we can basically plug this here and plug this here, put it in squared, move a here, and we possibly will receive a square equation. But quadratic equation. But let me show you a little bit faster way of doing this. And this faster way would be, I rewrite the top as this, because this is a formula, v final minus v1 and v final plus v1. It is like a squared minus b squared, and it is a minus b multiplied by a plus b divided over 2a. And so to get those and this, I actually subtract from this equation this, and I receive v final minus v1. From here I subtract there, and I see v0 plus at capital minus v0 minus at capital, and when I open minus over minus, it will be plus at, right? And I go, this is gone, this is gone, this is gone, this is gone, and it's a very simple equation. And by the way, this equation is the definition if I look on my main formula, V change in the speed equals AT, right? If I say that this is the beginning, this is V1 plus AT, it gives me the final speed. So this is exactly like that. So there is no surprises. But nevertheless. And now this would be my first bracket. And if I use this bracket, it would be I add those two. By the way, I'm doing here math. Physics stopped here. Now simply mathematical way of solving three equations with three unknowns. So if I plug this together and I sum, because I need this bracket, I will receive 2v0, because this plus this would be v0, plus 2at capital, and of course minus at. Fantastic. And so now I can continue here. I type d equals 2a at the bottom, and v final minus v1, it would be at. It's very good, because this a would be gone. And second bracket, I will have to write it in full. 2v0, right, plus 2at, and minus at. So this is gone. This goes here. 2d equals, t is a known number, so is this. So I can type t v0t. And then t is a known number, I have to multiply it here. 2a tt. T is a known number, I have to write it here, at squared. Very simple. Now everything with a stays here, everything without goes to another side. 2d minus 2v0t equals, and this is here, so a out, factor it out, 2t t minus t squared. Very nice. So let's put a here and t out, because we will be factoring it out, and we have 2t minus t. And then this on another side, we say 2d minus 2v0t. And I don't change signs, I simply take this side and I write it first. And this side as is, but I write it there. Okay? And so then I can write that a equals 2. And I can factor it out. D minus v0t, right? Divided over 2t capital minus t, and I have to multiply this by this t. So t goes here, becomes here. 2t minus t goes here. And this goes as is, but 2 is factored out. And let me double check my notes that I didn't make any mistakes now. And looks like I'm fine. So this is a formula, and notice in characters, generic case, I didn't plug the number right away, because if I would plug the numbers, it would be way more difficult for me to find an error if I did an error. And plus, if somebody gives me different numbers, I will have to redo everything from the very beginning. And plus, like for instance, we saw in a previous problem, when there was 3 times longer, it's not only for 1 second, it's for 1 hour, for 10 hours, it's always the same. So we lose some generic understanding of the problem. But now is a good time to plug the numbers. So we have to plug the numbers, but first, before plugging the numbers, we have to convert the units. And the only thing is this 360 kilometers an hour. And this is V0. And what it is, it's, let's convert it to the meters. 360 multiplied by 1000. meters an hour. And then an hour has 60 minutes, and every minute has 60 seconds. So we have 3060 seconds. So we have 360 over 1000, and we have to divide into, because we're converting to meters per second. Very nice. So we have those two are gone. And it becomes 10 by 10. 10 multiplied by 10, because 36 and 36 will be gone too, and it will become 100. So this is 100 meters per second, which is good, which is why they gave us such strange numbers. So everything will be cancelling out in the end, but you can use your calculator if you want. I don't have a calculator, so I use my brain. Sometimes I make mistakes, but that's okay. So now, acceleration. And I put 2, and instead of d I put 380, and then I put v0, and v0 is 100, and then I put t lowercase, it would be 2, and I go to denominator, I put bracket 2, t is 10 seconds, multiplied by 10, right, minus another 2, and finally this t would be 2. Very nice. So this 2 and this 2 is gone. 380 minus 200. 380 minus 200 would be 180. 20 minus 2 would be 18. 18 over 180 over 18 would be 10. 10 meters per second squared. It's very nice. And if they want to find V final, this is piece of cake now. V final equal V0 plus A over T. V final, V0 is known, is 100 plus 10, and T is another 10, right? So we have 10, 100 plus 100, 200. 200 meters per second, and if they want to convert it to kilometers an hour, it's double. We can do this exercise again, but it's just obvious that it's 720 kilometers an hour, because 360 is 100 and we have 200, so double it up. So let's conclude this problem. As always, don't forget to subscribe, don't forget to bell, don't forget to like, don't forget to like. If you have a comment, write it out. If you have a question, write it out. If you have a problem, write it out, and I try to solve it. Thank you very much.